Second go at this. I accidentally deleted the first one. Lesson 3, the national grid. I'm going to start with the story of Tesla and Edison. Tesla, we believe, was autistic, an amazingly intelligent man, a polymath. However, not a salesman. Edison, on the other hand, had invented the light bulb. He employed 200 people to do all the research for him. He was a hell of a salesman. He was very good at selling within geek space. And the battle was on for what form the national grid was going to make. Now, the national grid is a series of interconnecting power supplies all over Britain. So if you have solar panels, you're contributing to the national grid. And the idea being that at any one point, you're distributing the electricity to all the houses and industry. So those solar panels on your house, while they might be providing electricity for you, most likely they're actually going out onto the grid and you're drawing electricity from all over Britain. It does mean that should your panels fail or the wind not blow, you'll still get electricity. So these two guys, one of them was proposing that the national grid would run on alternating current. If you remember, alternating current is the idea that electricity flows in both directions, positive direction, negative direction. I'll let you know for now, Tesla won because we have a frequency in the UK of 50 Hertz. In America, they run their electricity at 60 Hertz. So if you've ever looked at a TV screen through a camera and noticed that flickering coming from the screen or from the light, that's what you're actually detecting, that on and off quick flashing. But up against him was Thomas Edison. And Edison was proposing the national grid should run on just positive charge, DC, charge direct. And direct is what you'll get from a cell, plus minus, and the idea of the electricity just running in one way. You also get in solar panels. Now, to try and sell the idea that DC was better, Edison would go around to fairs and he would talk to people to try and convince them that it was safer. And he would provide two generators, a DC and an AC, and he would electrocute people. And he would set a very low voltage on the DC and then lie and set a very high voltage on the AC to prove it was dangerous. And he electrocuted all sorts of things. He started small, he electrocuted pigs, electrocuted sheep, horses, and eventually his ultimate was poor Topsy. And here's a photograph of Topsy taken in the early 1900s. The man would try anything to try and push his cause. He provided a faulty AC generator for New York's first electrocution. It was billed as being clean, safe and modern, and it in fact took over 15 minutes to kill the prisoner, and all the accounts written, it was quite horrific. And if you've ever watched the film The Green Mile, that was the inspiration for that scene, and you'll know the one I'm on about if you've watched it. So, how did Tesla win in the end? Well, Tesla knew that you were going to need to have to avoid a problem, and the problem was with heating. This is the last video, so I'll just delete it now. If we cut over to this little clip here, I think it's this one. Here we go. Here we've got somebody running electric current through a wire. And if we look closely, let me refresh this. Here we go. I would have shown you this in person, but if we look closely at the wire, as the current flows through, it gets hot. There's too much resistance, there's too much current. The energy is given to the atoms vibrate and they change state and they go to a liquid, and we call that melting. So how were we going to distribute energy all around the national grid if we were creating power stations here and transmitting the electricity through to people's houses? How were we going to prevent the wires from getting hot and giving off all the energy before they finally get to the house? And the trick is that equation I taught you in the previous lesson. If you remember, power is equal to current squared times the resistance. So if we could get this current number as low as possible, then the amount of power loss would be very low. And that's where alternating current comes in. This is a transformer. Going in is the voltage. Well, across it is a voltage. Let me just get off that again. Come on, let go. You're going to let go? There we go. Across it is a voltage, plus minus voltage, a potential difference. And that causes a current to flow. And you don't need to know it yet. This is a year 11. But what you'll eventually see is, there we go, what you'll eventually see is that magnetism will be given off. And this thing's completely electrically isolated. This wire on the primary coil is in no way touching the secondary coil. But because the magnetism flows, it creates a potential difference across the wire, and that causes a current to flow. And so you can transfer electricity through magnetism. And if you've got an electric toothbrush, that's how it charges. There's a little coil of wire inside the charger. You put your toothbrush on top, and there's a coil of wire here, and that charges up, and it means there's no electrical connections, there's no hole inside your toothbrush, and you can't get electric shock. So what does that mean? Well, that means if we put in a small voltage here, in this case 120 volts, if we change the number of coils, we can greatly amplify the voltage. Now, if you remember back to the power equation of power equals current times voltage, what we're not doing here is we're not increasing the voltage. The power has to remain constant. You can't create more energy per second. You'd violate the laws of science. So if the current if the power stays the same, but the voltage increases, then the current has to do the opposite. It has to go down. So this is one of those Thunderbird relationships. And that's the key to it all. If we look here, we come out at around 20,000 volts from a power station. We step it up in a transformer, which turns it into 400,000 kilovolts, 400,000 volts. But just before it gets to you, it needs to step down. So it goes into your house at 230 volts. And if you're plugging in a phone or a small electrical device, you'll plug in a small transformer yourself, a little white iPhone charger, that kind of thing. And those will step it down to 5 volts. Now, the science behind it is this equation, I squared R. And a nice little example is if we took the current down from 2 amps to 1 amp, we see immediately we've dropped the power loss by 4 times. So that's the game. You drop the current as much as you can, and that will reduce the power loss in the wire. So, to summarise, we use AC in a transformer to step up the voltage, so the current decreases. Because power is equal to I squared R, this reduces the power loss in the wires. I'm going to enclose another link as well, and it's all about this in terms of where I learnt about Tesla and Edison. Hopefully you enjoy it as well, something a bit different, and good luck. Leave your comments in the box below. Cheers.